Hi. So once you've mastered the basics of surds, which we looked at in the previous video, then you can move on to this, which is rationalising the denominator. So if a third appears on the bottom of a fraction, we often rewrite it so that it appears on the top, and this is what rationalising the denominator is all about. So, for example, if you are asked to rationalise 2 over root 3, what we do is, because we want to get rid of the square root on the bottom, we multiply the fraction by this fraction here, root 3 over root 3. The reason that this is fine to do, it doesn't change the value because root 3 over root 3 is 1. So the fraction's value doesn't change, but what it does allow us to do is multiply, because when we multiply fractions, we multiply the numerators and then we multiply the denominators. So what it allows us to do is multiply the denominators together, and we know that root 3 times root 3 gives us 3. So now we've got 2 root 3 over 3. So no third on the bottom, and we have rationalised our denominator. So another example, slightly more complicated this time. We're going to rationalise 4 over 3 plus root 5. So this time, instead of just multiplying by a root over a root, because we've got 3 plus root 5 on the bottom, what we're going to do is take that, change the sign to a negative, and multiply by 3 minus root 5 over 3 minus root 5. And hopefully the reason that we've done that sign change will become clear in a minute. And again, it doesn't change the value of the fraction because 3 minus root 5 over 3 minus root 5 is 1. So you can see here that what we've done is we've multiplied the tops, the numerator, together. So 4 brackets 3 minus root 5. And then we're going to multiply the denominators. So you can imagine there are brackets around these denominators. And we use FOIL or whatever method you use to multiply 2 brackets together. So the first term here is 9. 3 times 3 is 9. The second one, when we do 3 times minus root 5, is minus 3 root 5. Then when we do root 5 times 3, we get the 3 root 5. And when we multiply the last 2 terms together, because root 5 times root 5 is 5, but in this case there's a negative here, so we end up with minus 5. Then we can collect up our like terms on the bottom. So 9 take away 5 gives us 4. And you can see here that minus 3 root 5 plus 3 root 5 equals 0. They cancel each other out. And that's why we chose the opposite sign initially. And then because we've got 4 on the top and 4 on the bottom, we can actually cancel those or divide the top and the bottom by 4. And we end up with 3 minus root 5, which is the answer.